All right, in this example, we have a real life application of solving a system of linear equations using a matrix. I'm going to spare you finding the inverse in this situation, but we are going to construct the matrix or construct the system of equations. So it shouldn't be too painful. Hopefully, once we've read through the text, we can figure out what's going on. So we've got a colony of 1,000 mole rats in this example, and they're divided into three categories. We've got adult males, adult females, and youngsters. Now, what we'll have to do is define what each of the variables is going to be. So we can say, first of all, let x be the number of adult males, just simply because that's the order in which they've been written. Okay, and similarly, so that's the first thing. Next thing, we're going to define y, so that's going to be the number of adult females. That's my shorthand for number. All right, and then you probably guessed it, we're going to use the letter Z. So let Z be the number of youngsters. All right. All right, so we've defined the three variables. So we've got X, Y, and Z. And we can now set up three equations based on the information that's been presented. So if we look at the first sentence, we're told straight away there is a colony of 1,000 mole rats, which comprises the adult males, adult females, and youngsters. So that means that if I add together the X, the Y, and the Z, that will give me the total number of the mole rats. So if I do that, that's going to give me a total of 1,000. So it's going to be X plus Y plus Z is equal to 1,000, which is good. So we've got one equation there, and that's from just this first sentence right here. We're then told in the next sentence that originally there were 100 more adult females than adult males. So we can set up an equation purely in terms of the males and the females now. So if there's more adult females than adult males, that means that if I take the adult females, that's the greatest number. Okay, and then if I find the difference between the adult females and the adult males, so in other words, if I do y subtract x, y being the number of adult females, this is going to give me an answer of 100, because there is 100 more y than there are x. So the difference must be 100. Now, the problem with this, of course, is the way I've written it, the x and y are in the wrong places to construct the matrix. So we'll deal with that problem in a moment, but we've got the information transformed into an equation, which is what we want. So that's dealt with that second sentence there. So we now need a third equation. So we're given a new scenario whereby after 1 year, there's been some changes in the numbers of males, females, and the youngsters. And then we're given a total change of number by 20. So there's been a decrease of 20 mole rats. Right. So let's have a look at how we can construct this third equation. So the number of adult males has increased by 2%. So this is going to ask you to write down a multiplier for 2%, just harking back to your GCSE days. So that's going to be 1.02 increase. We have another increase here of 3%. This is going to be 1.03. So I'm just going to clear some space on my screen. Now we've defined our variables. All right, let's go back to that. So 1.03 for the second bullet point, and then for the third bullet point, we've got a decrease this time of 4%. So 100 subtract 4 is 96, so the multiplier is going to be 0.96. The total number of mole rats has decreased by 20. So that means that if I find the sum of all these three, we're going to have 1.02, which is my 2% increase of the males, plus the 1.03 increase in the females, plus the slight decrease in the number of youngsters. Now, that is all going to equal 20 less than the original total. So that's going to be 1,000 subtract 20, which of course is equal to 980. So that's going to be our third equation. So now I've just written out the three equations, and I've put the x and y in the correct position so we can write the 3x3 matrix. All right, so let's write this as a matrix multiplication equation. So looking at the coefficients, we've got 1, 1, and 1 for the first row. We have -1, 1, and then 0 for the second row. And then we have 1.02, 1.03, and 0.96 for that third row. So that's the matrix that's going to multiply our variables contained in our 3x1 matrix, or our column vector, which contains x, y, and z. All right, and then that's going to equal the right-hand side of the equation, which is 1,100 and 980. Okay, so if you like, we could call this matrix here A. And to solve the system of equations, remember, of course, that if I'm solving these equations, I've got A multiplied by the column vector x, y, z is equal to another column vector, which is 1,100 and 980. So to use an inverse matrix for this, multiplying on the left-hand side by the inverse of A. Now, again, this will create the identity matrix for a 3x3 square matrix. So we can denote that as I3. It depends completely up to you, or just I. So that product is just going to be the identity matrix I3 with ones down the leading diagonal and zeros everywhere else. And then on the right-hand side of this equation, we need to compute a to the -1 multiplied by our 3x1 matrix here. And we know from previous experience, computing that inverse matrix is going to be a bit of a problem. So I've sent you a link explaining how to do this on your ClassWiz. Unfortunately, my ClassWiz emulator is not working, so I can't show you on the video, but you can plug in each of these elements from the matrix A into your ClassWiz, and it will compute the inverse matrix for you without having to do it by a longhand written computation. Okay, so the next step is going to be, we're going to state what the inverse matrix of A is, and then we're going to solve this equation. Okay, so this is the inverse matrix for A, which I've computed on the ClassWiz. Now, to solve the equation, or the system of equations, which is what I should have said, we simply have to multiply this column vector here by this inverse matrix. And again, you can do this on the ClassWiz. So x, y, and z is simply going to be 1/13. Then we've got all this, so -96, -7, 100, -96 again, 6 and 100. incidentally, you can set up the equations in whatever order you like. It doesn't matter as long as you're consistent all the way across. With the right hand side of the equation as well, it doesn't matter one bit. Right, and then we know that we're multiplying by 1,000, okay, 100 and 980. So you could do this manually, or you could use your ClassWiz for this. It's completely up to you. Once again, we're going to take the first row, multiply that by the first and only column right there. Let's see what we get for this. So I'm going to just write down what we get. So it's quite simple. So we get X, Y, and Z. And our final answers are going to work out very nicely. We're going to have 100. All right. We're going to get 200 for Y, and for Z, we're going to get 700. Okay. So therefore, we know that X is equal to 100, Y is equal to 200, and Z is equal to 700. And just a nice way of doing this, you could do this using simultaneous equations, and you can also use something called row operations to generate your inverse matrix, but it's completely up to you. For the exam, you can use your calculator to find this inverse matrix, okay? But I do want you to have that skill in the bank, just so if you are confronted with an inverse matrix and you have to compute it, you know what to do. Okay, so that concludes this example.